Okay, this outcrop is in the Jurassic Carmel Formation. It's a member of the formation dominated by shaly limestone, or you could call it limey shale. The idea there is the shale implies that there are thin beds of fine-grained sediment, and the limey part implies that they are made of calcium carbonate, and they do indeed react with hydrochloric acid. You can see a prominent feature right here, a structural feature that comes up and then splits into a few different other components, and then also has a bit of a fold over the top of it. So that is a fault, and I want you to think about what kind of fault that might be. All right, second exercise at this stop, I'm going to try to explain strike and dip. I'm going to try to do this from behind the camera, and we'll see how it goes. The last video I did of this, the compass was too hard to see, so I want to try it again. So this is a geologic compass. Oh, there you can see my face. It's got a mirror on it for a variety of reasons. That's the least important part right now. What I want you to focus on are the black arm that's sticking out, and then the arrow in the center that's sort of vibrating with the white tip to it. That's the compass direction arrow. And if you can see, as I rotate this, that arrow points in the same direction no matter what. It's pointing towards magnetic north, which, reminder, isn't the same as true north. So this compass has been adjusted so that 0 is not actually at the north, it's off a little bit. So it's been adjusted for the magnetic declination of this area. If we look inside the compass, you can see that there is a sort of greenish yellow level, which sort of makes a bullseye. And then there's another level right by my pinky there, and that's the barrel level. The greenish one is used for measuring strike, and the barrel level is used for measuring dip. So in the next video, I'm going to go measure strike and dip, and we'll see how that goes. All right, we're looking at the undersurface of a fault plane. All right. So faults exist in planes, and we can measure them then using a geologic compass. And we're going to try to use this compass with the right-hand rule method. So what I'm going to do is I'm going to take the compass and put it up against the rock, and I'm going to wiggle it around until the bubble gets into the bullseye of that green level. Now for right-hand rule, we want the dip, so the direction that the rocks are dipping, to be oriented on the right side of the compass relative to this arrow here. So in this case, we're underneath the surface, which can make it a little more challenging sometimes. All right, so it's in the bullseye, and there's normally a little white bubble that I can press, or button, to freeze it, but I can't do that right now, so I'm just going to have to take a sneak peek and see that it's about 45. I'm going to double check it. It's always good to take multiple measurements. More like 50. So, and that 50 that it was pointing to was right here, and that is in the southeast quadrant. So this strike would be south 50 degrees east on what's called a quadrant compass. And that implies that if you were facing directly south, the orientation of this plane is then rotated 50 degrees from south towards the east. Now to measure dip, we're going to use a different level, and I'll do that in a separate video. So a reminder for dip is going to use that level there, and I'm going to put the compass up against the face of the rock, and I'm going to rotate this, and that rotates that level. This is much harder than I thought it would be. And then that will give me a reading in this part of the compass. On this one, I don't have to hold this white button down because I'm not worried about the compass arrow. And as long as I don't move this, the dip doesn't move, and the dip in here is pointing to, it's kind of obscured, 33. Right, so it's pointing to 33. I don't know if y'all can see that, 33. And because we're using right-hand rule, if the strike is to the southeast and the dip is 90 degrees to the right from that, the dip is to the southwest. So 33 degrees to the southwest. That will help you guess what kind of fault this is.